Hello guys, welcome back to Math Zone African Motives. We are still on our revisions and we are going to consider this part of our mathematics N4 which was written on the 26th of March 2026. All right, so that was our X paper that we are going to consider a 3-hour paper. So we are going to see, guys, according to what we have. Make sure that you go through the instructions. It was out of 100, and the answers are supposed to be given to 3 decimal places. All final answers must be rounded off to 3 decimal places, all right? Unless indicated differently or stated differently from the given question. All right, so let us see what we had. Question number one. So that is, we are given question number one, and 1.1, it was draw a neat graph. All right, so from here we can see that this is an ellipse, all right, that we are given here as these coefficients. I mean, they are different. So that is an ellipse that you're given, which we are supposed to have in the form x squared over a squared plus y squared over b squared is equal to a constant 1, which is the best way that we can have from the intercepts. So to obtain that, we simply need to rearrange our equation. We can take the negative to the other side of the equation. So it's going to be 9x squared plus 4y squared is equal to 36. So to obtain a 1, that is the major case. To obtain what? A 1, we have to divide by the constant, which is 36. Throughout the equation, divide by what? By 36. So that was going to simply give us 4 here. So that's x squared over 4 plus 4 into 4, that's 1, into 36, that's 9. So that's y squared over 9. And this is going to give us a 1. So as we can see that from the format, a squared, b squared, that is the 4, and the 9 that we have can be actually written 4 is 2 squared. So if you want, you can actually rewrite as a 2 squared, then y squared over what? 9 is same as 3 squared, that's equal to 1, where a and b represents the intercept for x is equal to a and y is equal to b as our intercepts. So that's the value of our x here is going to be 2. That's the intercept. Simply plus or minus 2. Then y is going to be at what? At 3, which is simply plus or minus 3. So we do understand, guys, as we are to have our ellipse that has the x-intercept. So here I'm just going to have a sketch of how it was going to look like at the end. So having the x-intercept in this. So that's approximately, just gonna use our points. This is the x-intercept, that's 2. All right, so that's 2 approximately somewhere here, and negative 2. Then positive 3 as you're going up, maybe it was gonna be somewhere here, and negative 3 for the y value. We have got positive 3 and negative 3 here. So that is, you are going to have your ellipse. Just join the points. All right, from here to this one, from there to here. All right, that's something like this, but just draw something that is neat, guys. All right, so that is what you're going to have at the end from the given equation. 9x squared plus 4y squared minus 36 is equal to 0. It was actually an ellipse that you're having. All right, then another part you are given this year, draw this graph. All right, that's y minus log x base e, right? So if we're going to take this to the other side, that's y is equal to the logarithm of x in base e, which is a ln of what? X. Remember, log x base e is equal to what? The ln of x. So guys, we do understand that the graph of a ln crosses the x-axis or passes through the x-axis at 1. That is something of this nature where it cannot cross or pass through the what? The y-axis. The y-axis is actually our asymptote where x is equal to 0. It is limited. It cannot cross that. So that is the graph that you are given. Simply, that's the graph of a lane. The lane of what? The lane of x, right? And what is the domain of this graph? As we can see, it is limited from the y-axis where x is equal to 0. Our values, they are supposed to be from 0 going this side. That is greater than what? Greater than 0 from the y-axis. So our domain, x must be greater than what? Greater than 0 for any real number that is greater than 0. All right, draw. On 1.3, we are supposed to draw this graph. Okay, so that is from here. If you're going to take this plus to the other side, that was going to be a negative. So y is equal to negative the square root of 25 minus x squared. Are we seeing that? Here we are simply dealing with a semicircle. Remember from our introduction, y is equal to negative the square root of r squared minus x squared. That's a semicircle which is found below the x-axis, all right? It is below the x-axis from the negative. If it was a positive, above the x-axis. So r being the radius, we can see from 25, y is equal to negative 5 squared. 25 is same as what? 5 squared. So that's our radius in this case is what? Is 5. So we are simply going to have a semicircle with a radius of what? 5 units, right? Below the what? Below the x-axis. So that was going to be something like this, right? So that's x and y. That's our origin. Let's say this is negative 5. This is going to be positive 5. And this is going to be negative 5, just like that. So you're going to have your semicircle below what? Below the x-axis, as we have got a negative here. So that was it on question number 1. As we can see direct from what we had as part of our introduction, we can simply use that. All right, so make sure that you join membership so that you do not miss introductions to these topics that we are answering. All right. Question number 2, 2.1, you are given to apply or to use the Cramer's rule. All right. So there we have, all right, this 3, 5 in the denominator. So simply get rid of the denominator from the first equation. Our LCD between 3 and 5 is going to be what? 15, or the LCM. So you're going to multiply each and every term by the what? By the LCM, which is 15. So 3 into 15, that's a 7 if you divide. So it was going to be like this, 7 into x minus 3. 5 into 15, that's a 3. So that's plus 3 into y plus 4. So it's going to affect y plus 4, the whole of this part. So that's equal to 7 times 15. You multiply those 2, 7, and 15, which was going to be 105. All right, let's try to have our proper equation. Simply distribute, expand the bracket. So the first one by 7, 7 times x times negative 3, that's negative 21. 3 multiplies the second bracket. 3 times y, that's 3y times 4, that's a 12, and that's 105. Simplify this, that's 7x, 3y, all right? And we have got negative 21 and a positive 12. All right, so that was that is 3 into 15. That's a 5 here, not a 7. This is a 5. Pardon my calculation here. This is what? This is a 5. So 5 times 3, 5 times x was going to be 5x times negative 3, negative 15. All right, so let's do correct that. So that's 5x plus 3y minus 15 and 12 is going to be negative 3, which is 105. So 5x plus 3y is equal to what? Take the negative 3 to the other side. That was going to be positive 3, which is what? 108. So that's our first equation, all right? From what we have, we are going to do the same thing on the second equation. just consider the LCD of the denominators. This is over 1. So 7 and 2 and 1 is going to be what? 14. So multiply by what? By 14 here, by 14 here, by 14, all right, here, each and every term. So 14 divided by 7, that's a 2. So it's going to be 2 into x plus 2, all right? Then here 2 and 14 is going to be negative 7 if you divide into the bracket of what? Y minus 6. So that's equal to negative 3 times 14, which is negative 42. So let us try to expand the brackets and see what you're going to have. 2 times x, 2 times 3, 2 times 2, that's what? A 4. Negative 7 times y, negative 7 and negative 6. That's a positive 42, and that is equal to negative 42. Looking into the left-hand side, that's 2x minus 7y in this case. Then you're going to consider adding 4 and 42, which is what? 46. And that's equal to negative 42. So 2x minus 7y is equal to what? Take the 46 to the other side. It's going to be definitely a negative 46 that you have. So that's negative 88 from here. That is what you're going to have. So that's our second equation. So using these two equations that we have formulated, we can apply our Cramer's rule to solve for what? To solve for x and y. So let's take these two equations, sorry for that, these two equations that we have formulated from here. The first one, all right, this is going to be our first equation, and this is what? Our second equation. So that is what you're going to have, guys, and we can simply use our Cramer's rule to solve for x and y, since we do understand x is going to be delta x over delta naught. That's two unknown values that you are having. So that's as easy as that. And y is going to be delta y over delta naught. So that's our delta x. In place of x, you're going to put what? The constants, which is 108, negative 88. Then the part of y remains as it is 3 and what? 3 and negative 7. Determine that determinant. Then you do the same thing for the determinant with respect to y. So this part, substitute with what? These constants. So the first part of x is just going to remain as it is, 5, 2. But this part of y, you're going to put these constants, 108 and what? Negative 88. So that's it. You're going to have your determinant. Then for the constants, delta naught, you take this part as it is, 5, 2. So that's 5, 2, 7, what? 3 minus 7, sorry. So determine your determinant. Remember, 2 by 2 from here, A, B, C, D. Determinant is going to be AD minus BC, A times D. And you subtract B and C, the major diagonal minus the minor diagonal. So that's simply here, delta x, 108 times negative 7. Then you subtract 3 times what? Negative 88. So that's it, guys. Use your calculator properly to determine these determinants. That was going to be negative 492. Then delta y, we do the same thing. Considering AD minus BC, our delta y is going to be 5 and what? Negative 88. All right, minus 108 and what? And 2. 108 times 2. So that was going to give us our delta y in this case, which is negative 656. Then we do the same thing for the constants. 5 and what? Negative 7. 5 times negative 7. 3 and what? 3 and 2. So that's minus 3 times what? 3 times 2, like this. So our delta naught is going to give us negative 41. So with this information, we can have the value of x from this formula. So x is simply going to be delta x negative 492 over delta naught, negative 41. So that's the value of x, which is what? Which is 12. And y is equal to delta y, which is what? Negative 656. And your delta naught, negative 41. Y was going to give us 16 from here. So that is basically what you're going to have on 2.1 if you were to remove the fractions and have proper linear equation that you are used to, all right? Then let us consider another part, 2.2. Evaluate this, all right, from given. We are supposed to determine the determinant. Expand only along what elements of row 1. So we are considering row 1. This is our row. These are rows like this. These are columns. So the row 1 is the first one that is on top. So on the first row, you know, the sign is going to be plus, minus, plus like that. So that is expanding. You can determine the determinant. Remember, guys, I simply said the determinant. You're going to consider the constant the number to the sign that you have. So 3 with a plus. So that's plus 3. Then you determine the determinant if you close the column and that row that where 3 is. So if you're going to close this part of the column, you're going to remain with this. This is what? A 2 by 2 that you're going to remain with. 7, 9, 8, 6. You move on to the next one, which is in that given what? In that given column, in that given row, I mean, the next number is what? Is 2. So 2 corresponds with what? A negative. So that's negative 2. You find the determinant when you close what? When you close this row where 2 is and the column where 2 is. So you're going to remain with 4, 9, 4, 9, 1, 6, 1, 6, like that. So you do the same thing when you move on to another part. The last term in that row is what? 5, and 5 corresponds with a positive. So that's positive 5. The determinant that corresponds, if you close the row and the column where 5 is, you're going to remain with what? 4, 7, 1, 8. So that is the condition that you're going to have. And from this, you can have your determinant of the given condition using this. You can have, just like the previous case, guys, our AD minus what? Minus BC. So that was going to be positive 3. All right, positive 3, then you consider 7 and what? 7 and 6 minus 9 times what? 9 times 8. So that is the first one. The second one, considering that there's a negative 2. So you've got 4 and what? 4 and 6 minus 9 times what? 9 times 1. So this is what you're going to have. Right, that's 9 times 1 here. And the last part with the positive what? A positive 5. Then the determinant corresponding 4 and what? 4 and 8. Then we subtract 7 versus what? 7 times 1, like that. So guys, this is what we had from our introduction. So we can simplify the determinant of the given. That is simplify, you're going to have here. That was going to give us negative 13 minus 2. Then simplify this, you're going to obtain positive 15 plus 5. Then simplify this whole part, you're going to obtain positive 25. So that is our determinant at the end was simply going to give us a positive 5. Okay, so that was expanding the first row. Expanding the first row, you had an instruction to work with. We are working from an instruction. So that was it on 2.21. Let us consider another part of our question just to cater for what we have. All right, the other part we are given here to evaluate the cofactor of the element 8, that's 2.22. The cofactor of what? Element 8. So this is where the element 8 is. If you were going to continue with this expansion, plus, minus, minus, plus, minus, plus, like that. We can see that the element 8 corresponds to negative. Remember, a cofactor is what? Assigned what? Assigned minor. So you consider the sign of what you are given. So that's cofactor of what? Element 8. Of element 8 is going to be the sign first, where element 8, it corresponds to what? A negative. Then you find the minor, assigned minor. What is the minor of element 8? Remember the minor, you close the row and the column where that element 8 is, you close the row and you close what? The column, and find the determinant of what is remaining, the 2 by 2. That is 3, 5. We are remaining with 3, 5, 4, and what? 4 and 9. We determine the determinant from there. That's, we now have a cofactor, assigned minor. So 3 and what? 3 and 9. 3 times 9 minus what? 4 times what? 5 and 4. 5 times 4. So that's it. We have got our determinant. We have got our cofactor from there. So that's negative of this value that you're going to obtain, which is 7. So that's negative times 7, which is what? Negative 7. So actually 7 is the minor of that element 8 multiplied by the sign. It gives us what? The cofactor, assigned what? Assigned minor. All right, simplify on 2.3. Have your answer in rectangular form. Right, so as we can see, this was easy. We just have to, okay, this is in polar form. Just rewrite as it is, 2 cis 126 degrees over what? Remember, this whole part is rectangular, which can be written in polar form, r cos theta plus I sine of theta is equal to r cis theta, or r angle of theta, like that. So that's, in this case, we can see that this is the same thing, 72 degrees, 72 degrees. The first one has a cos, the other one has a sine. So we can rewrite that one in what? In polar form as r cis theta in our polar form, from rectangular to polar form. So our r is what? 2. So that's 2 cis theta. The angle theta is what? 72 degrees. Everything is being raised to the exponent of 3 that we're given there. All right, so remember, in polar form division, r cis theta, like 1 and 2, like this, you're simply going to divide these two, r1 over r2, but as of the angles, you're going to subtract theta 1 minus theta 2, you subtract. So you're simply going to divide 10 divided by 2, which is what? That's going to give us a 5. So that's 5. And the angle, you subtract 126 degrees minus 72. You subtract that one. That was going to give us 54. So that's 54 degrees being raised to the exponent of what? Of 3, as we are given. So remember, from the De Morgan's theorem, that if we are given something like this, r cis theta raised to the exponent of n, r is going to be raised to the exponent of n, but the angle is going to be multiplied by what? By n. So r to the exponent of n, that's 5 to the exponent of what? Of 3. Then as of the angle, any times theta, any multiplies the theta, the angle, the 54 degrees. So that's 3 times what? 54 degrees, like that. So 5 to the exponent of 3, that's simply 125. The angle, 3 times 54, that's 162. Remember, we are in polar form here, but the answer is being required to be given as per instruction to rectangular form. So rectangular form is this one that we have of r cos theta, which can be written as r cos theta plus ri sine of what? Of theta. So from what we are given, this can be written as, our r is this one, this is our theta. So that's going to be 125 cos theta. cos what? 162. All right, plus R again, 125 times I there, or you can use the letter J. All right, so that's sine of what? Theta. Our theta is 162. It is now in what? In a rectangular form when it is like this. But we can just simplify, that is to obtain exact values from what we have. 125 cos 162 is going to give us this, and we can even round off or fix our calculators to 3 decimal places as per given instruction. So that's negative 118,882. Then we simplify this 125. That's 125 sine 162. The answer is going to remain with the I at the end. So 125 sine of what? Sine of 162 is going to give us 38,627. So that's a positive 38,627. 627 with what? With this I at the end. So you must have that one. It is just an unknown value, just like unknown, just to say X or Y. So it must be part of your answer at the end. In what? In a rectangular form. So that was the requirement from what we are given, all right? If we are to consider having these steps, all of them in polar form. So you have to consider this part in order for you to have the six marks that you're given. All right, that is it. Then question number 3, which is part of our trigonometry. All right, so this was a direct equation, as we can see. This is phi. Then here they're just putting something else. Let us just put phi there. So this was a direct equation. We can just consider 3 sine squared of phi like this, right? For the given interval that we are given from 0 to 360, that was something that was direct in actual sense, because here we do not have something to worry about. From 0 to 360, there is no need of even having the general solutions. Then you find exact solutions. You can simply use or apply quadrants in this case, as we do understand from quadrants. They are taken from what? From 0 to 360. So every application can be taken from a quadrant. All right, so we're going to see that at the end. In order for you to solve this is a quadratic equation. The highest exponent is what? Is 2. So that's a quadratic. We can use our quadratic formula. If we had to solve for x, let's say this was x, we're going to write x is equal to, but they were solving for what? Theta, which is the sine of theta from our equation. So the sine of phi, is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. I doubt factorization was going to work here with a negative 5 there, all right? So this is our a or b or c. So that's the sine of phi is equal to negative b, which is negative 4, plus or minus the square root of b squared. Our b is what? Negative 4, but being squared, minus 4 times a, which is 3. Our c is what? Negative 5. Everything over 2 times 3. Our a is what? Our a is 3. So that's 2 times 3 there. All right. Sorry for that. Let's see what's taking place. 3 there. So you can simplify what is under the square root just for the sake of seeing properly. We can just evaluate everything at once. So negative, negative, that's a positive. Then we're going to have the square root of what? Let me just bring back my calculator to the normal mode. So that's minus 4 squared minus 4 squared minus 4 times 3 times negative 5 as it is here. That was going to give us 76, a positive. All right, everything over 2 times 3, which is 6. So we can have the solutions from this quadratic equation, 2 solutions representing the sine of what? The sine of phi, like that. So we're going to have 2 solutions. From the positive one, it was going to be 4 plus the square root of 76 over what? Over 6. which is 2,1, 2,1193 decimal places is going to give us, okay, 3 decimal places is going to give us 2,120, 2,120 like that. Or the sine of angle phi is equal to putting a negative. If we had to consider a negative here, it was going to give us what? Negative 0,786, negative 0,786 to 3 decimal places. So the first one, we cannot have a solution. Remember, the sine of the angle phi, to have exact solution, it must be taken in a consideration if it is equal to a is supposed to be greater than 0 but less than 1, less than 1. So we are supposed to have values in between, actually not greater than, but something like this, -1, greater than -1 but less than 1, in between. From -1 to +1, we can take the value of A representing the sign. So here you can see 2 is out of that interval. So meaning to say from the first part, it's actually not applicable, undefined. You cannot have a solution there. But if you do not understand this concept, what you can simply use, all right? Remember, you're supposed to find what? The reference angle. So it was going to be what? Arc sine of 2,12. Can you have that? All right, let's bring our calculator. Sorry. That is going to be what? Arc sine here. Shift, you press sine. Arc sine of 2,12. We can see that no value can be determined. That's an error that we have. So here it is not applicable, no solution. To this one, yes, it is in within this interval, greater than -1, but less than 1. So there is, or there are solutions here. We're going to have what? Solutions. But like I said, with the interval that we are working with from 0 to 360, there is no need of us using the general solution concept because of what? The interval that you're working with. Simply consider where sine is negative from our cast concept. Sine is positive in this and this quadrant. So therefore it is negative. As we can see, our sine is what? Negative. Therefore it is negative. In which quadrant? In the fourth quadrant, where we have cos as a positive. In the fourth and what? In the third quadrant, their sine is going to be what? Negative. Where the solution to what you're calculating the angle phi in the fourth quadrant is 360 degrees minus the reference angle. In the third quadrant, we know that these angles are taken from what? 180 degrees plus what? The reference angle. Those will be the exact solutions. So let's find the reference angle. That's arc sine of what? 0,786. You take the magnitude of this, you ignore and take the magnitude. So our reference angle was going to be arc sine. All right. So that's arc sine, shift to press sine of 0,786. So this is what you're going to have to 3 decimal places, 51,813 degrees. So now the exact solutions, which is the angle phi, is going to be from the third quadrant, all right? From the third quadrant, 180 plus reference angle. So that's 180 plus our reference angle, 51,813 degrees. So our angle phi was going to be 231,813 degrees. Or we're going to have another one from 0 to 360, another one in the fourth what? In the fourth quadrant, where phi is taken as 360 degrees minus what? The reference angle. Our reference angle is what? 51,813 degrees. So that's from our fourth quadrant. You're going to have the angle phi in that case, which was 308,187 what? 187 degrees. So that is basically what you are going to have at the end if you are to consider your simplification from what you're given. That is how to evaluate or to solve. In this case, we have to solve. So there are two solutions from 0 to what? From 0 to 360 as we are given here from what? 0 to 360 degrees. So that was it for this part. simply like that, you can simply use your quadratic formula and solve where it is possible. All right, let's consider another part, which was 3.2. It was actually to simplify this. To simplify, it is just like where you are given to prove, like this, only that to prove you are given an answer already. There is what? There's an answer. But to simplify, you are not given the answer. You're supposed to write it in the simplest form. So that's here, the cosec, or you can just even extend it from where it is. So let's just have it. Remember, cosec, we have to get rid of the cosec, the cot, the tan. So cosec is simply 1 over the sine of x, plus the cot, that's cos of x over what? The sine of x. All right, let's check from what you're given. From here, we can see that our trigonometry part is actually limited. These identities we actually do not have. So you're supposed to know these basics, guys, all right, from our introduction. Remember, we talked about this, so you must know the basics. So this is what you're going to have from what we are given. This whole part is over what? The tan, that's sine over cos, the sine of x over the cosine of x, plus the sine of x is same as what? Sine of x over 1. So what I can simply do, since I have a fraction in the numerator to be combined and another one in the denominator, all right? The numerator, simply combine here. The sine of x is the same. We've got the same denominator. So our answer is going to be under that same denominator. Just add what? The numerators together. So it's going to be 1 plus the cos of x over what? That common denominator, which is the sine of x. When the denominators are the same, simply combine a over b plus c over what? B is the same as a plus c over b over that same denominator that you're given. But in the other case, we are supposed to simplify. There is this fraction in the denominator, so you can just write as divided by. Then we're going to simplify this. The LCD cos x and 1 is going to be cos of x. So divide cos x and cos x, that's 1. Then 1 times the numerator sine x. It was going to be sine x plus, we divide here cos x divided by 1. That is going to be cos x. Then you multiply to the sine of x. So that's sine x times what? Times cos of x. This is what you're going to have. Remember, we're dealing with a division. Where there is a division, we are supposed to introduce what? A multiplication. So we introduce a multiplication and invert or change the second fraction. That's going to be cos x over the denominator, which we can factorize as what? The sine of x is common. So as we are writing our denominator, we can just simply factorize it. That's going to be 1 plus cos of x remaining. So this is it. We can see that this one cancels. Where it cancels, guys, the numerator denominator concept do cancel, as the 1 plus cos of x, this part cancels with this one. This is going to be 1 and 1. So here you are left with 1 over the sine of x times cos of x over the sine of x, which we cannot cancel the denominators. So we can just rewrite in simplest form. 1 over sine is what? Is cosec x. All right. Then cos over sine is what? It's cot of x. This one cannot be simplified further. There is nothing that we can do. So it means it is actually in what? In simplest form, as we cannot simplify it further. We cannot cancel anything here. So that is basically what you're going to have at the end. So we have to expect, yes, questions like that in our final examinations. It can be like that. As we can see, there was given in our April 2026 exam. Let us consider another one, 3.3. Given this, we are supposed to write it in what? In terms of sine of theta only, sine of theta. All right, let's play around. 1 over sec we take it, right? We know that 1 over cos theta is what is the sec of theta. So the opposite, 1 over this is going to give us what? Cos. So 1 over the sec of 2 theta is simply a cos. So that's cos of what? 2 theta. Remember, we can expand the cos from our identities here. If we are given the cos of A plus B, all right, it is going to be, if you're given this is going to be, all right, cos A, cos B plus minus, yeah, if it is a plus, it's going to be minus sine A, sine B. So that is the one that you're going to take with what? With a positive. But how is that possible? Because we have 2 theta. 2 theta simply means theta plus theta, guys. That's theta plus theta. So you take this one as your A and this one as your what? As your B. So it was supposed to be cos, cos, sine, sine, cos of A, cos of what? Of B, minus sine of A, sine of what? Of B. But A and B are the same. So it is simply going to be cos of theta, all right? Cos of what? Cos of theta, minus sine of A, sine of B, which is sine of theta, sine of what? Of theta. So cos times cos, that's a cos squared. Sine times sine, that's a sine squared. In terms of what? Sine theta only. So we're supposed to get rid of what? The cos, because we need a sine. Is there any identity that we can use? Yes, we have from our Pythagorean identity here. We can play around and make cos the subject. So you're going to take the sine squared to the other side. So that is cos squared x is 1 minus what? Is 1 minus sine squared x. So if it is like that, it means the cos squared theta, this one, the cos squared theta can be written as 1 minus what? Sine squared theta. So in place of that, we can replace with what? 1 minus what? Sine squared theta, because we need it in terms of sine theta only, all right? But remember, there was already this minus what? Sine squared theta. So let's simplify. That's 1. Yes, simply collect like terms. Minus 1, minus 1. So minus 1, minus 1. That's minus 2. So that's minus 2 sine squared theta. So that is where it is going to reach. In this case, we only have sine theta on our answer. We do not have a cos or any other part. It's just a sine on our answer. That is what you're being given. All right, let us see from here. 3.4 prove that, all right, the left-hand side and the right-hand side is equal. We can work with the complicated part, which is the right-hand side, given the cos squared of x minus the cos of x minus sine squared. So remember, we can just write both of cos and cos. So the sine squared of x, remember, it's 1 minus what? Cos squared x. So just write that as what? 1 minus cos squared of x in place of the sine, so that we don't waste our time here. And the denominator, sine of x, is common. We can factor it out and have 2 cos x plus what? Plus 1. So that's it. If we factor out the sine of x, that is what you're going to have. And let us try to simplify what we have from the numerator, expanding our brackets. It was going to be cos squared x minus cos of x minus times 1, that's minus 1, minus times minus, that's going to be plus cos squared of x. These are like terms. So 1 plus 1, that's going to be 2 cos squared x minus what? Minus the cos of x minus what? Minus 1. Everything over these two, the sine of x into 2 cos x plus 1. The numerator can be factorized, so simply here try to what? To factorize so that we can have at least something as the denominator. So using your ways of factorization, like I said, consider the videos for grade 10 mathematics on how to factorize, grade 11 and grade 12 mathematics on how to factorize using any method that you understand. So that's, I'm going to take cos of x so that we can easily understand cos of x. I'm going to refer it as x or even k, all right? So it's going to be 2k squared minus k minus 1. So using the cheat method, there's a method that I explained from grade 10 and 11, yes, about the cheat method, where we can cheat and take the 2 to multiply -1. So it's going to be k squared minus k. 2 times -1, it's -2. So we cheated so that we can have what? A proper quadratic where the coefficient of k squared is what? Is 1. So this is going to give us k and k. And considering factors of -2, which will add up to -1, that's -2 and 1. Multiply this, you get a -2. Add, you get a -1. So those are factors, or what? Products. -2 and 1. Then you bring back that 2 that you cheated in place of k. Wherever there is k, you put that 2. So you're going to put the 2, you put the 2 here, you factorize what is in the bracket is our answer in the brackets. So you factorize where there is something common, like the first bracket 2 is common. So it's going to cancel here and have what? K minus 1. This is 2k plus 1. The brackets will be our answer. So this 2 is useless. So remember, k represents what? K represents cos x. So this is cos x minus 1, cos of x minus 1, 2k, so that's 2 cos of x plus 1, over what? The sine of x into 2 cos x plus 1. So the factorization is in your hands, guys. Here, it is in your hands. Do it the way that you understand from the previous grade and so on and so on. So it is just a matter of revision, which is very, very important. So we can see that these two brackets are the same, so they can cancel from what we just obtained. And from these, we are going to obtain what? That is the numerator over the denominator, which we can also separate as well. The cos of x minus 1 over what? Over the sine of x that is remaining. Since these two terms are separated from here, guys, you can see this on its own and this one on its own. They separated these terms. So we can also separate. Remember, this is a proof. So you must write as you are given. So separate the terms, the cos of x and what? Sine of x minus 1 and what? Sine of x. So that's cos x over the sine of x minus 1 over the sine of x. Remember, a minus b over c. A over c minus b over c. We can separate over the same denominator. So cos over what? A sine, that's a cot. Cot x. 1 over sine, that's cosec. So that is cosec of what? Cosec of x. And this is exactly what we are given on the right-hand side. So that's what? That's proven. We managed to prove that identity. So that is how sometimes these questions can be given, as you just have to play around with the given information where it is necessary, expand this and that. So that is revision, guys, all right? Question number 4, expand this 1.1 to 4 terms. That's definitely our binomial theorem. All right, so remember, guys, I just dealt with this type where I said try to just apply the derivative concept. How do we apply the derivative concept? X plus 2y, these are the two terms that you are going to consider. So from the expansion, you take the first term raised to the exponent of 7. So x, you raise it to the exponent of what? Of 7. Then 2y, this one is useless because it is raised to the exponent of 0 for that moment over 0 factorial. So thus, plus the part of x which we had, the exponent here, you drop the exponent, just like derivative, x to the exponent of 7, you drop the exponent, then you subtract 1. So that's going to be 7x to the exponent of 6. The part of y there increases in terms of what? The exponent was a 0, now it's a 1 over what? 1 factorial on the exponent. All right, plus you do the same thing. This is now 7. You drop the exponent on that x to the exponent of 6 drop the exponent, subtract 1. So that's 6 here, x to the exponent of what? 5. So you drop the exponent, you subtract 1, all right? Then the part of 2y is increasing the exponent 1, now it's 2, over what? The factorial 2 of what? The factorial of 2. So that is what you're going to have, and so on, plus this one you rewrite as it is 7 and what? 7 and 6, as it is 7 times 6. Here you drop the exponent, all right? So that's 5. Then you subtract 1, 5 minus 1 is going to be 4, whereas y is increasing. So it's 2y to the exponent of what now? To the exponent of 3 over 3 factorial. That's how we can simply apply, but guys, we know our formula. So we can simply use our formula direct, or we can just apply this concept. So here, like I said, this first part is actually useless because it's raised to the exponent of what? Of 0. So you can even just ignore it, all right? So x to the exponent of 7, all right, plus, let's simplify here. So this is going to be just like 7 times 2 to the exponent of what? 2 to the exponent of 1 over 1 factorial. So you're going to simplify it as in this format or in this manner. All right, that was going to give us 14. So that was 14 y to the exponent of what? 1. But x is to the exponent of 6, y to the exponent of what? 1. So that's simply y that you're going to have. So that's how you simplify that. Here, you're going to multiply on the third one, 7 and what? 7 times 6, and 2 raised to the exponent of what? 2 over what? 2 factorial. That's how you simplify on your calculator. That was going to give you 84 x to the exponent of 5, y to the exponent of what? Y to the exponent of 2. All right, the last one, you do the same thing, 7 times 6 times 5, 7 times 6 times 5 times 2 raised to the exponent of what? Of 3. 2 to the exponent of 3 over what? 3 factorial. That's how you use your calculator. That was going to give you 280 x to the exponent of 4, y to the exponent of what? Of 3. So this is what you're going to simply have from this simplification, right? As we can see, just a matter of revision, just a matter of revision from what we have. All right, then 4.2, determine the limit of this. And we can simply see that this was a matter of factorizing the numerator. You can use that cheat method that I used before. Any method that you understand, guys, you're going to have x plus 1 into 2x minus 1 by what? By factorizing. The denominator, x is common, so you're going to factorize, and it's going to be 2x squared over x, which is what? Which is 2x. So that's 2x minus 1, x and x is going to cancel. So that's it. These two brackets are the same. They're going to simply cancel as x approaches to what? 1 over 2. So that is what you're going to simply have. And this was going to be limit as x approaches to 1 over 2 of what? X plus 1 over x. Substitute x, which is, 1 over 2 in place of x in the numerator. So that's 1 over 2. 1 over 2 plus what? Plus 1 over what? In the denominator, x is 1 over 2. So simplify this, guys. You can simply use your calculator to simplify this. That was going to give us a 3. The numerator was going to give us 3 over 2. The denominator is 1 over 2. So dividing this was going to give us a 3 at the end. So that is basically what you are going to have from this simplification. All right, on 4 point what? On 4.2. That is what you had, right? 4.3, we are being asked to differentiate this using function of a function. So the function of a function is where we introduce u in place of another function. So you can replace it here as the cube root is same as what? to the exponent of a third. So this one, in terms of x, we're going to introduce another function u to represent that in terms of x, our f of x, which is what? X squared minus 1. So therefore, this equation is now written as y is equal, this part is represented by u. So that's u to the exponent of a third. Remember that we can find our dy dx from the chain rule, which is our dy dx is going to be dy du times du dx, just like that. So we need to find these derivatives from here. Dy du, simply drop the exponent, subtract 1, all right? So that's a third u to the exponent of what? A third minus 1, that's minus what? Minus 2/3, okay? Then here you do the same thing, du dx, now drop the exponent, subtract 1, that's 2x, minus 1, that's a constant, it's going to give us a 0. So that's it. Let us combine them into this formula. Dy du, that's a third u to the exponent of minus 2/3 times du dx, which is what? Which is 2x. So I can actually get rid of this negative. It's going to be 1/3 u to the exponent of 2/3. But remember that x to the exponent of m over n is the nth root of x to the exponent of m. So that was going to be 1 over, in this case, it is going to be 1 over what? 3. Then this one, the u to the exponent of 2/3 from this law, it is going to be the cube root of u squared. So that's the cube root of what? U squared times the 2x, all right, over 1. Then we can substitute because our derivative must be in terms of what? Must be in terms of x. So dy dx, we have to get rid of that u. So substitute with its equivalent. U equals what? X squared minus 1. So you're going to substitute with x squared minus 1. That was the case. So this was going to be 1 over 3, the cube root of what? Our u, which is x squared minus 1, being what? Being squared. So that is the condition. This is the square root of this. So this is it. All right. Then you're going to multiply by 2x. So multiplying by 2x, simply you can have that one here. Since we have 1 times 2x is what? Is 2x. This one times this one, just like that. So that is how you can have your answer at the end from this derivative that you're given, just like that. All right. So you can see, guys, easy like that. It's a matter of working out more questions. Differentiate this using the quotient rule. All right, this is 3 ln x. Guys, you see the way that I took it from, okay, no problem. Let us save this one and see what we're going to have. So the quotient rule, this is u, this is v. So that's on 4.4. Our dy dx was going to be given as v, the first derivative, and this is u, v, v prime over v squared. So our u is the numerator, the cos of x. So its derivative is negative sign. Remember from your formula sheet, the derivative of a cos is going to give, the derivative of a cos is going to give us what? Is going to give us a negative sign from here. Cos is going to give us a negative sign. So that is what you're going to simply need from that. That's negative sign. And our v is 3, the ln of x, and the derivative of a ln is 1 over x. So it's going to be 3 over x, right? So that's it. Let's substitute into our formula, our v, that's 3 ln of x. 3 ln of x times the first derivative of what? Of u, which is negative sign of what? Negative sign of x, minus our u, which is the cos, that's the cos of x times the derivative of u, of v, which is 3 over x. So that's 3 over x over what? V squared. Our v is 3 ln of x. So that's 3 ln of x like this being squared. So we can actually leave our answer like this if we are not to consider simplification at the end. We can just leave our answer because nothing is common that we can factor out this and that. So we can just leave our answer like this. Okay. Still, it is okay like that. If we are to consider the formula and having it like this is still one and the same. So 4.5, let us see for 9 marks. Differentiate, we're supposed to differentiate each and every part with respect to x. So that's with respect to x, the sec of x, all right? Let's start from there. We have it from our formula sheet. The sec of x is going to give us sec tan, all right? So that one was direct. It's going to be sec tan. So that's 2 sec tan, because there's a 2 there, so it's going to be 2 sec of x, tan of what? Of x. All right, then there's cosec 2x here, so minus 4 times the derivative of a cosec. So cosec is going to give us negative what? Negative cosec cot x, negative cosec. So if we have a number like this on that cosec, which is the 2, you take that 2, so it's going to be negative 2, then you write cosec of what? Of 2x, cot of what? Of 2x. You take that 2, this one on the constant, on the x, the coefficient of x, you multiply by it. So that's negative 4 times negative 2, which was going to give us what? Positive 8. So it was going to be positive 8 cosec 2x, cot what? Cot 2x. Just like that, all right? So this is cosec 2x cot 2x. Let's move on to another one. 6 ln of x. The ln of x is 1 over x times 6. So that's 6 over what? That's 6 over x, just like that. 5 to the exponent of 4x. Remember, when differentiating, if we're given a to the exponent of f of x, its derivative is going to be f prime x times a to the exponent of f of x times the ln of a. So our f of x is what? Our f of x is what? Is 4. Its derivative, our f of x is 4x. So its derivative is 4 times a to the exponent of that f of x, which is what? 5 to the exponent of 4x times the ln of a. Our a is what? Is 5. So it was going to be like this, just like that. So here there's nothing that we can do, add or subtract. So it's just going to be like this here. That's a positive. So that's plus this. All right. Then let's move on to another one. We have got 1 over 2 cot, right? So take note, 1 over cot. It's going to be 1 over 2 times 1 over cot. From a tan, 1 over tan gives us cot. 1 over tan x is cot x. So meaning to say 1 over cot is what? Is tan x. So here it means 1 over 2 times the tan of what? Tan of x. Then we can differentiate the tan of what? The tan of x. So it was going to be plus 1 over 2. The derivative of a tan is what? That's a sec squared, all right? So that's sec squared of x, all right? We move on. The next one here is negative 3, the cube root of x, which is negative 3. The cube root of x means x to the exponent of a third. So remember, derivative were like this. We drop the exponent, subtract 1. So minus 3 times a third. X to the exponent, we subtract 1, so that's minus 2/3. So that was my cancel. And you have minus 1, which is minus x to the exponent of minus 2/3. So here we can get rid of that negative on the exponent. It's going to be x to the exponent of 2/3, which simply indicates the cube root of what? That's going to be the cube root of x squared, right? From here, it's going to be the cube root, this one, in the root sign. The numerator is our exponent with a negative, all right? So that is what you're going to have at the end with a what? With a negative. So you differentiate each. Then you move on the derivative of p. P is a constant, so its derivative gives us what? A 0. All right. There we've got minus 1 over 4, all right? E to the exponent of a negative. The moment we take it up, it's going to take what? It's going to have a positive exponent. Rewriting. Then if we differentiate e to the exponent of x, it remains like that. Remember, the derivative of e to the exponent of x. Are we given that one separately? All right, they didn't give us that, but we can check it from the concept of here, e to the exponent of x. It was going to be e to the exponent of x times the ln of e, where the ln of e is what? Is 1. So you remain with what? E to the exponent of x. So the derivative of e remains like that. That's e to the exponent of x. So that's simply minus 1 over 4 e to the exponent of a positive x. All right. Then plus x cubed. Drop the exponent, subtract 1. So that's plus 3x squared. You drop the exponent 3, then you subtract 1. So that was it. From this derivative, you are going to have something like this, differentiating each part, that is each part up to the end. This is what you're simply going to have. All right, let's consider 5.1, where you're given evaluate. All right, there 5.1 evaluate, that's our integration. So take note, sine 2x, remember that's equivalent to 2 sine of x cos of x from our double angle identities. So that was integral. Pi over 2, you can use it as it is, or you can change to degrees. Pi is 180 degrees. So 180 degrees over 2 is what? 90 degrees. So it's simply going to be 90 degrees, 0 degrees. Remember, sine 2x is what? 2 sine x cos of x from our double angle over the cos of x. We have this one. We are supposed to be given. Do we have our double angle here? Oh, we are not given. It's just this part of our compound and our Pythagorean. So unfortunately, you are not given. So you're supposed to know that and work from what you understand. All right. So here we can cancel the sine, the cos and the cos. So we're going to remain with the sine. Then integrate that sine that you're given. From this, we can simply integrate 2 sine what? 2 sine of x with respect to x. If we integrate a sine, it is going to give us a negative cos. From our integration is going to give us a negative what? A negative cos. So that's a negative cos, which is 2, negative 2 cos of x. From the given limits, that's from 0 to 90 degrees, if you have to consider degrees. Or you can use these, but you have to apply your calculator in what? In radians. But using these degrees, your calculator in what? In degrees. Minus 2 cos of the upper angle, which is 90 degrees, minus 2 the cos of what? The lower angle, which is what? 0 degrees. So this is going to give us negative 2 cos 90, that's a 0, minus, you simplify negative 2 cos 0, that was going to give us a negative 2. So minus minus, that's a positive, and 0 plus 2 is what? Is a 2. So at the end, you're going to simply obtain a 2, just like that. Integration is something that is direct, the opposite of your what? Your derivatives. If you understand your derivatives, you're done. All right, here we are asked to simplify again. Let us consider sine over cos is what? A tan. So that's the integral of what? 3 sine over cos is what? A tan. So this 3 tan x plus pi over x. All right, so plus pi over x. We can take the pi and just remain with the 1 over x, like this, with respect to x, plus 7, a constant with respect to x. So that is 3. The integral of a tan is given as what? A tan is ln sec of x. So that's ln sec of x. We have it from a formula sheet. So that's 3. The ln sec of what? Of x plus pi. 1 over x is simply the opposite. We do not have it direct here, but we know, all right, or we have it here, a over x, all right? They gave us here a over x is a ln x, a the ln of x. So we have that one direct. That's a ln of what? A ln of x, which is pi over, pi ln of x, pi the ln of x, or constant, it's pi. Then 7 with respect to x, 7 is a constant, so the integral of a constant is going to give us what? 7x times x with respect to x. Do not forget the constant of integration, just like that. 5.3, on 5.3, we've got 5.31, let's sketch these two graphs, all right? But we need also to calculate the points of intersection of the two graphs, y and y, guys, they're simply the same. So to find the points of intersection, for the points of intersection, simply equate the two graphs. 4x squared is equal to what? To 2x, then solve for x. So to solve for x, take this one to the other side. 4x squared minus 2x is equal to 0. Using the highest common factor factorization, 2x is what is common. So you're going to simply factor out 2x. 4x squared divided by 2x, that's 2x minus 2x and 2x, that's minus 1, which is equal to 0. So using the product concept, which gives us a 0, a times b to be equal to 0, it's a must be 0, b must be 0. So that's 2x is going to be equal to 0, or 2x minus 1 is equal to 0. That's it. So simply divide by 2 by 2. Here, take this to the other side. That's 2x is equal to 1 divided by 2. X is 1 over 2. So as of the points of intersection, we do understand that these two equations will be the same. So you can substitute the values of x in any of these two equations. I'm just going to use the second one. Y is equal to x. When x is a 0, substitute there. That's 2 times 0, which is a 0. So that's a point of 0 versus 0. And another point, when x is 1 over 2, substitute 1 over 2 here. That's 2 times a half, which is what? Which is going to give us a 1. So that's a half versus 1. So those are the points of intersection that you're going to have. And from the sketching of the graph, we can see that, all right, using these points of intersection when the two graphs are equal. Right, let's try to sketch from what we can see. Remember, these are points of what? Points of intersection. So in order for you to sketch this graph, we can simply see that here we've got the graph of y is equal to ax squared, where a is greater than 0. It is what? Concave up, having or symmetrically to the what? To the y-axis, when it is simply ax squared. So in this case, it was going to be like that. All right, symmetrical and being concave up, symmetrical about the y-axis and what? And being concave up, passing through the origin and being symmetrical to the y-axis. So that's the graph of y is equal to what? 4x squared. And the graph of y is equal to 2x is simply a linear or a straight line where you can simply use the points when x is equal to 0, y is 0. When x is equal to 1 over 2, y is 1. So you can draw that line like that. Okay, that's the line of y is equal to 2x. So the points of intersection, that's 0, 0 at the origin, and this one, which is 1 over 2 versus 1, where the x value is what? 1 over 2. So that was it, and we can see that by showing the area, this and that, and the strip that is to be used, the strip from the values of x as our limits, we can have the representative strip for what? For x. So that's delta x. And the area to be calculated is the one that is bounded by the two graphs. So this is the area to be calculated, bounded by the two graphs. So that is it. just like that. Then with the aid of integration, determine that area bounded by the what? The two graphs. So that's 5.32. So the area with respect to x can be what? Can be calculated, as we do understand that area when the two graphs are being enclosed, you can use the formula given from your formula sheet y2 minus y1, simply the one on top minus the one on the bottom, because you can even use as y1 minus y2, as long you understand that the one that you are saying, the one that you're subtracting is the one on the bottom. So top minus what? Top minus bottom. So that is what you're going to have. That is the integral of y2 minus y1 according to our formula sheet with respect to x, x1 and x2. Those are the limits a and b, or you can write as it is x1 and x2 according to our formula sheet. So the one on top in our case is what? The linear, that's our y2. The one below, which is the bottom one, is what? Y1, which is our 4x. So that's y2, the one on top, 2x minus what? Y1, which is 4x squared. So this, when integrated with respect to x, and substituting the limits with respect to x from 0 to 1 over 2, the lower to the upper limit, whatever that you're going to have represents the area bounded by the two graphs. So let's integrate, guys. This is 1. Remember, integration, you add 1. So that's 2x to the exponent of 1 plus 1, which is 2. Then you divide by the new exponent 2. So that was going to give us x squared. So that's x squared here, minus 4, you add 1 on your exponent. So that's minus 4x to the exponent of 3 over the new exponent 3. So that's minus 4x to the exponent of 3 over 3 from what? 0 to 1 over 2. Using these limits, we can simply substitute and find our area at the end bounded by the two graphs. Upper limit in place of x, that's 1 over 2 squared minus 4 times 1 over 2 cubed over what? Over 3. So this is the upper value minus the lower value when x is equal to what? When x is equal to 0. So that's simply 0 minus 0 like that. So that was it, simplifying this from what we have. That was going to give us the first part of our calculation, which is 1 over 12, all right, minus 0. So 1 over 12 minus 0, that's 1 over 12. So that's our area, which we can also have as a decimal as 0,083 to 3 decimal places. So that's our area in what? Square units. The area bounded by what? The two graphs. We are considering the two graphs that you are given. So the area bounded, all right, with respect to x, with a strip for x, that's with respect to what? With respect to x. So that is how you're gonna evaluate such integrals, all right? Integral for what? For area. Derivatives for those tangents, gradients, and so on. So that is it here on 5.4. We are now asked to integrate the following, just like what we had before. We can integrate each and every part separately. All right, so let's try to do that and see how you're going to have the final solution. So that's all right. Here we've got a cos. So remember, when integrating cos, changes to a sign, but we have this 1 over 2. So you are supposed to divide by it. So it was going to be like this 3, the sine of 1 over 2x. You're supposed to divide by that coefficient of x, which is 1 over 2. So as we can see, it's now 3 divided by what? 1 over 2. 3 divided by 1 over 2, which is what? Which is 6 in that case, all right? So that was going to give us a 6. That's a 6 sine of what? Half x when simplified. So that's 6 sine of half x, all right? Minus a to the exponent of negative x. Remember, when integrating such a to the exponent of f of x, you're going to have to need a to the exponent of f of x over its derivative times the ln of a. So a to the exponent of what? F of x. As it is, it's just going to remain as it is like this over what? The derivative from our f of x. Our f of x is what? Negative x. What is its derivative? It's -1. So that's -1 times the ln of a, which is the ln of what? A as it is. It's already a as it is. So just ln of what? Ln of a. So negative was going to cancel and give us what? A positive. So you can write it as it is, or you can take it down and have it as 1 over the ln of a times a to the exponent of x as a positive, or you can just have it like this. It's still one and the same. So that's what's going to be 1 over the ln of a times a to the exponent of x, just like that. Then the last one, it is x and algebraic, so you can get rid of the cube root of x. So it's 1 over x to the exponent of a third. When you take it up, it's going to be a negative third. Remember, when integrating, you add exponent. So it's going to be x to the exponent of 2 over 3 divided by the what? New exponent, 2 over 3. So 1 divided by what? 2 over 3. 1 divided by 2 over 3 is what? 3 over 2. X to the exponent of 2 over 3. So that's 3 over 2 of this, or simply the cube root of what? Of x squared, like this. So this is going to be the simplest form of our integral. Do not forget to add what? The constant of integration as you are integrating. So that was basically what you're going to have. So let us do revise in light as we are preparing ourselves for the exams ahead of time. Just try by all means go through the topics, all the introductions, as we have every topic as of our syllabus. So do also join the membership to support our channel, and also as for you guys to get access to other videos which are meant for members only. So that is it, guys. Till we meet again.